Hello everybody. Today we're going to be finding the distance between 2 points using the distance formula. Essentially this is a different form of the Pythagorean theorem which we talked about yesterday, so it's going to have very similar results. So here we go. All right, so to find the distance between 2 points, you're going to use x2 and y2 and x1 and y1. Now, essentially all you have to do is plug the corresponding values into the locations here, 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 and here. Now, this really isn't too bad. You just got to make sure you're able to subtract accurately. You square everything, then you add those two things together, then take the square root. So, starting one, my first 2 points are 11, 7, and 5, negative 1. So I'm just going to designate this as x1, this as y1, this is x2, this is y2. So plugging x2 in, I have 5 minus x1, which is 11. That's going to be squared. Then I'm going to take y2, which is negative 1, and I'm going to subtract 7y1, and then I'll square that. Now this is all underneath a radical, so you need to include that. Now we're just going to simplify. 5 minus 11 is negative 6. Negative 1 minus 7 is negative 8. Still under a radical, so I'm going to put that there. Negative 6 squared is going to give me 36. Negative 8 squared is going to give me 64. Adding those together, I'm going to get 100. And the square root of 100 is 10. So the distance between these 2 points is 10 units. So that's a good start. We get a nice little whole number. That is not always the case, so you have to be able to adjust based on how it's provided. So let's try this one now. Example 2 in your notes, I have 0, negative 2, and 5, negative 1. I'll color code this time. So let's say this is x1, this is y1, and this is x2, and this is y2. So plugging these in to the formula, x2 is negative 5. I'm going to subtract x1, which is 0 here. I should have made that red. Let's just put that there now. Now, that's going to be squared. I'm just going to copy everything. That should be black. y2 is going to be negative 1, and I'm going to subtract y1, which is negative 2. Now, because that's negative, I'm going to put that in parentheses. You'll see why in a second. Now, to simplify everything, negative 5 minus 0 is going to be negative 5. That's going to end up being squared. Negative 1 minus negative 2. This ends up being added because subtracting a negative is the same thing as adding. So negative 1 plus 2 is going to give me 1 squared. Remember, all of this is still under a radical. Now I just have to simplify. Negative 5 squared is going to be 25. Those parentheses are important, remember. 1 squared is going to give me 1. So I end up with the square root of 26. And 26 is not a perfect square. Also, all of its factors are prime numbers, so there aren't any perfect squares that come out of it. So my final answer is square root of 26, which is approximately equal to, like we did yesterday, the decimal 5.10. So the distance is square root of 26, or approximately equal to 5.1 units. Do a couple more examples here. Again, I want to designate x1, y1, and x2, y2, and then I'm just going to plug the numbers in. So, x2 is negative 7. I'm going to subtract x1, which is 4. That's going to be squared. Then I'm going to add y2 minus y1, which is 8. Again, that's going to be squared. So negative 7 minus 4 is negative 11. Same signs, add and keep. Keep the parentheses so you make sure you cancel out the negative when you square it. 12 minus 8 is 4. Again, still an irradical. Negative 11 squared is going to give me positive 121. 4 squared is going to give me 16. 121 plus 16 is going to be 137. And I'm going to check to see if there are any perfect squares in 137. So, 137 does not have any perfect square factors, so this is my radical answer. But as a decimal, that is 11.7, approximately. So there's your final answer. Now this last one, again, I want to kind of designate x1, y1, and x2, y2. I have x2, which is 9. I'm going to subtract x1, which is 3. That's going to be squared. Then I'm going to add y2 minus y1, which is 8, and square that. 9 minus 3 is 6 squared. 10 minus 8 is 2, then squared. 6 squared is 36. 2 squared is 4. So I end up with the square root of 40. This time, this simplifies. So the largest perfect square that comes out of 40 is 4. So this is the same thing as 4 times 10, which is going to give me 2 square root 10 when I simplify that, which is approximately equal to the decimal 6.32. And there's the distance formula. So same rules as yesterday. If you have a radical answer, you're going to have to find the decimal equivalent. And yeah, if you refer back to that first example that we had a whole number, naturally we only have one answer. But every other time, because there was a radical with an imperfect square, I end up with a decimal answer as well. So there you have it. Assignment starts here on page 14. There's 10 questions, and you need to show your work every single time. I would be sure to write out the distance formula just to kind of remind you. I have x2 minus x1 in parentheses squared. Then I add y2 minus y1, again in parentheses squared, followed by the square root of whatever that gives you. So there's the distance formula. I would write it down so you don't have to constantly look at your notes. It's just a good idea to have this memorized. Essentially, all you got to do, subtract the x's, square the result. Subtract the y's, square the results. Add those two numbers, then take the square roots. So that's all I got for you. Go ahead and get started on that assignment. And as always, make sure you come see me with any questions that you might have. All right, good luck, and thank you.